Forces and motion. Section 1. Gravity, a force of attraction. Key concept. Gravity is a force of attraction between objects that is due to their masses. Have you ever seen a video of astronauts on the moon? The astronauts, such as the one in Figure 1, bounce around like beach balls, even though they wear big, bulky spacesuits. Why is leaping on the moon easier than leaping on Earth? The reason is that there is less force pulling the astronauts to the ground when they leap on the moon than when they leap on Earth. Gravity is a force of attraction between objects that is due to their masses. The force of gravity can change the motion of an object by changing the object's velocity. The effects of gravity on matter. All matter has mass. Gravity is a result of mass. Therefore, all matter is affected by gravity. That is, all objects experience an attraction toward all other objects. This gravitational force pulls objects toward each other. For example, gravity between the objects of the solar system holds the solar system together. Gravity affects smaller objects too. Right now, because of gravity, you are being pulled toward this book and every other object around you. These objects are also being pulled toward you and toward each other. So, why don't you notice objects moving toward each other? The reason is that the mass of most objects is too small to cause a force large enough to notice. However, you know one object that is massive enough to cause a noticeable attraction: Earth. Earth's gravitational force. Compared with all objects around you, Earth has a huge mass. The gravitational attraction of Earth is thus an important force that you experience all the time. Earth's gravitational force pulls everything toward the center of Earth. Because of this force, the books, tables, and chairs in the room stay in place, and dropped objects fall to Earth rather than move together or toward you. You must apply forces to overcome Earth's gravitational force any time that you lift objects or even parts of your body. Newton and the study of gravity. For thousands of years, people asked two very puzzling questions. Why do objects fall toward Earth, and what keeps the planets moving in the sky? The two questions were treated separately. But in 1665, Sir Isaac Newton, a British scientist, realized that they were two parts of the same question. The core of an idea. The legend is that Newton made the connection between the two questions when he watched a falling apple, as shown in Figure 2. He knew that unbalanced forces are needed to change the motion of objects by changing the velocity of the objects. He concluded that an unbalanced force on the apple made the apple fall. And he reasoned that an unbalanced force on the moon kept the moon moving circularly around Earth. Newton said that these two forces are actually the same force, a force that he called gravity. The birth of a law. Newton summarized his ideas about gravity in a law now known as the law of universal gravitation. This law describes the relationships between gravitational force, mass, and distance. The law is called universal because it is thought to apply to all objects in the universe. The law of universal gravitation. The law of universal gravitation states that all objects in the universe attract each other through gravitational force. The magnitude of the force depends on the masses of the objects and the distance between the objects. Understanding the law is easier if you consider it in two parts. Part 1. Gravitational force and mass. The gravitational force between objects depends on the product of the masses of the objects. So, the gravity between objects increases as the masses of the objects increase, as shown in Figure 3. For example, an elephant has a larger mass than a cat does. Thus, gravitational force between an elephant and Earth is greater than the gravitational force between a cat and Earth. So, a cat is much easier to pick up than an elephant. There is also gravity between the cat and the elephant. But that force seems very small because the cat's mass and the elephant's mass are so much smaller than Earth's mass. This part of the law of universal gravitation also explains why the astronauts on the moon bounce so easily. The moon has less mass than Earth does. Therefore, the moon's gravitational force is less than Earth's. The astronauts bounced around on the moon because they were not being pulled down with as much force as they would have been on Earth. Part 2. Gravitational force and distance. The force of gravity depends on the distance between two objects. If you jump up, you are pulled back down by Earth's gravitational force. But the Sun is more than 300,000 times more massive than Earth. Why doesn't the Sun's gravitational force affect you more than Earth's does when you jump up? The reason is that the Sun is about 150 million kilometers, or 93 million miles, away. The force of gravity changes as distance changes, as shown in Figure 4. As the distance between two objects gets larger, the force of gravity gets much smaller. For example, if the distance between two things is doubled, the force of gravity becomes 1/4 as large. Figure 5 shows how the force of gravity gets smaller as the distance between objects gets larger. The Sun is very far away from you. So, the Sun's gravitational force on your body is very small. However, the gravitational force between the Sun and the planets is large because they all have such large masses. The large gravitational force of the Sun affects the movement of all the planets. This force helps them stay in orbit around the Sun. So, the force of gravity has an important role in maintaining the shape of the solar system. Weight and gravitational force. Gravity is a force of attraction between objects. Weight is a measure of the gravitational force on an object. Therefore, weight is expressed in the SI unit of force, the Newton. When you see or hear the word weight, it usually refers to Earth's gravitational force on something. But weight can also be a measure of the gravitational force exerted on things by other planets, or even by the moon. The differences between weight and mass. Weight is related to mass, but they are not the same. Weight changes when gravitational force changes. Mass is a measure of the amount of matter in an object. Mass is usually expressed in kilograms or grams. An object's mass does not change when gravitational force changes. Imagine that an object is moved to a place where it would experience a greater gravitational force than on Earth, such as the planet Jupiter. The object's weight will increase, but its mass will remain the same. Figure 6 shows the weight and mass of an astronaut on Earth and on the Moon. The Moon's gravitational force is about 1/6 of Earth's gravitational force. Gravitational force is about the same everywhere on Earth. Because the weight of an object is constant as long as the object remains on Earth, we often get confused about the difference between weight and mass. Be sure you understand the difference. Gravity and static objects. Like all forces, gravity can cause objects to move. But gravity also acts on non-moving or static objects. Earth's gravity pulls static objects downward, but they do not move downward because gravity is balanced by an upward force. For example, imagine a framed picture hanging from a nail. The gravity on the picture is balanced by elastic forces due to tension in the nail. What if you place the same picture on a shelf? Then the gravity on the picture is balanced by elastic forces due to compression in the shelf. In both cases, the picture is static.